Okay, cool. So welcome to this talk. My name is Victor Peterson. I am the co-founder of Screenly. And I'm going to speak today about our experience with Ubuntu Core. We've been using it basically since day zero. So yeah, we got a bit to cover. So what we do with Screenly is called digital signage. And you've probably seen these type of screens all over the world. A lot of them are broken, like this. Yeah. So essentially, what we do is to avoid that. We built a very robust and reliable digital signage platform, not running on Windows, and a lot more reliable. And in this talk, I will talk a bit about our experience with Ubuntu Core, how we got to where we are today, and basically reflect on that. And then we've got Ogar in the crowd as well, so I'm sure he will grill me on the details. Now, so how did we get into this weird space that's called digital signage, that a terminology that you didn't even know existed before we accidentally landed up in here? So me and my co-founder ended up taking over a deployment of screens in Sweden for advertisement. And this project, called Screenly OSE, is now the most popular project on GitHub. It's larger than 3 next projects combined in the signage, so it's by far the biggest open source digital signage project. Our commercial version is the one that's running on Ubuntu Core. And to my knowledge, it is the largest deployment of Ubuntu Core. And we started very early. So that's what I'm going to cover in this talk today. It started 10 years ago. This is the very first commit to the open source version back in 2012. So this has led us to getting all these kind of customers. And this is spread between the open source version, but we have some significant pickup of customers actually running their stuff on our platform. So that's where we are today. And what I want to speak about now is how we ended up here, and basically the mistakes we made and our experience with Ubuntu Core. So any of you guys remember this guy? Yes. It's the Asus EEE PC. It was probably the first affordable PC, like budget. It also came as a notebook and netbook, I think they called them back then. So it was essentially the first like really affordable PC, right? We started prototyping on this guy, and we started building out the very first version of Screenly OSE on this guy. It did run Ubuntu, I believe, 12.04. So that's how old it was, right? But a few months later, we came across the first Raspberry Pi. So when the Raspberry Pi was announced, we decided that this makes a lot of sense for us. So I was on the waitlist for the Raspberry Pi for about a few months. And in June of 2012, I got the first Raspberry Pi. We got very busy porting our software stack to the Raspberry Pi. It was essentially just getting it to work there. And we open sourced that. And we put up on GitHub. And it really took off like wildfire. And we have been reflecting on this in the past of why that is. And because we were so early, it was probably the first usable thing for Raspberry Pi. So there were a lot of open source projects out there, but none of them were polished enough to actually use. A lot of people were on the waitlist for the Raspberry Pi, they ordered them, and then now what, right? You could tinker with it, but you had no like commercial use case for it. Screenly OSE kind of changed that. So when we ported the Raspberry Pi to the Raspberry Pi, it really exploded from there. We never really intended to make a commercial version of Screenly. That was just inbound requests from customer after customer asking us like, hey, can you please provide like a managed version of this? And by that I meant like a central console they can manage all their devices, and as well as like a fleet management as well. It goes with that, right? So I hate to remind you, this is back in 2013, early 2013. Puppet was really popular. Those of you guys remember that. So Puppet were like the natural choice for us because it was like the most popular configuration management tool at the time. Looking back at that, that was a horrible decision for a large number of reasons. But long story short, we started writing Puppet and we deployed that to all these devices. So we started implementing that, and roughly we hit about 10,000 devices. That's when we were like, oh, this is not going to scale well. every run took 10 minutes or so on a Raspberry Pi. Like this is like a Raspberry Pi 2. Puppet is written in Ruby, super heavy, takes up all your resource on a Raspberry Pi, super slow, and it just didn't scale well. So one of the things we ended up with having a lot of issues with Puppet on the Raspberry Pi was because the run is so long, so like 10 minutes, the probability of somebody janking the power of that device for whatever reason during that is pretty high. And you guys probably know if you jack the power off a device in the middle of an apt-get upgrade of the kernel, bad things will happen, right? So we ended up spending a lot of time writing tooling to basically recover from broken states. And that's when, like, when we hit about 10,000 nodes, we started to realize that this is not going to scale to 20, 50,000 nodes. This is going to be a big pain point for us. So we essentially started going back to the drawing board. And this was at the same time as we had rewritten our complete player from scratch. So Screenly OSC were initially the version for the commercial version that we forked off, added some management layers. We started to hit some growth pains with that at large scale. So we essentially rewrote the entire stack from scratch. In Qt, it was highly performant. We did like something like on Raspberry Pi 2, I think we had 60 FPS with transitions on Raspberry Pi 2, which is pretty crazy. And this is kind of when we realized that Raspbian is not where we need to be. Like that's going to be a business problem for us in the long run. So we started to evaluate alternatives. And around this time period is when CoreOS, if you guys remember the logo, rest in peace, were really popular. And for good reasons. CoreOS had some really good features that we really liked. So we devised a list of what would the ideal setup look like for us on, if we were to like reimagine from scratch, what would an operating system look for an IoT device like a Raspberry Pi for us look like? So we came up with this checklist, right? So it was very important that the minimum footprint for the OS was very tiny. It's like a few hundred megs, right? Like super tiny because it's an attack vector. It's a device with a fairly small storage amount. So it needs to be very small and dynamic, right? Both from a security perspective, but also from a maintenance perspective, right? Again, going back to our bad experience with Puppet, transactional updates of both the OS and of the app itself was really important to us because we spent way too much time recovering from broken state. Ideally, we would also want cryptographic signing of these packages, right? So nobody could do like a man in the middle and inject like a rogue update, right? That was also very important for us. The other thing that was important was AD partitioning. So if for whatever reason a kernel update goes rogue, whatever, it breaks, having that automatic rollback was very important because keep in mind, these devices are often very inaccessible. Like they can be deployed in the ceiling, in a building. They're hard to get to. Like you can't just like cook in a keyboard and like recover it, right? These are, you deploy it once and it's supposed to live there for like 3 years without any interaction, right? Everything needs to be like rock solid. Process isolation was another thing that was very important to us. The major reason for that was because we support a lot of different type of content. One of those type of content is web. And web obviously is far less controlled than, say, a video file. So there are a lot more attack vectors for a web page. So we want to make sure that we can confine the runtime environment as much as we possibly can so that there's very little way of a process going rogue and taking over the system, right? And that was important to us. And the other thing was boot time, because keep in mind, these are public screens. You don't want to see a boot screen there, or you definitely do not want to see like a boot console log playing on like a 50-inch screen in like the lobby of business, right? That looks horrendous, right? So that was important. And the last thing we had was building disk images in CI/CD. Previously, it was a very hackish process to build disk images on Raspbian. Tooling for that has gotten much better on Raspbian, but back in those days, it was essentially like flash it out, make modification, dump the disk image, clean it up, and there was like a bunch of ugly bash script involved, right? So building that in CI/CD pipeline was really important to us because that way we could just fire off a job and like voila, now you have the latest disk image, send it off to manufacturing, boom, there you go. So back then, we had 3 choices to evaluate. You guys probably remember, this is a Snappy logo. So not even Ubuntu Core, that was a Snappy logo. So this is basically in the very, very early days of Ubuntu Core when it was still called Snappy. That was one of the alternatives we evaluated. The other one was Balena. And the other one was Yocto. But then with like Glued, we had to write ourselves because otherwise it would be, it's not enough. Like Yocto, it's great for building images, but it doesn't really have the management interface for like large-scale deployment. There are a third party that does that, but the bottom line is that we really wanted a partner that could do that for us rather than having to do that our own, because that's not our core business at the end of the day, right? So we ended up on Ubuntu Core. So how did it do? Well, actually pretty well. So the only thing, and Ogre's laughing, to this day is boot time. It's still dreadfully slow. Even on i5, first boot is dreadfully slow. Imagine how it is on a Raspberry Pi in manufacturing. And that's a massive pain point for us because when we manufacture devices, the difference between like 30 seconds and a minute and a half adds up to a lot of cost when you do QC in manufacturing. So that's still a pain point. I know Andre's working on some stuff to speed that up, but as things stand, that's still the case, right? So, but all in all, it's not a bad outcome given the circumstances, really, I must say. So we've been happy so far with that. Now, on to our experience with Ubuntu Core so far. Well, I'm gonna prefix this whole list here with this is how it is today. I'm not gonna mention the first few years where nothing worked. We could basically not build the image. We could basically not publish snaps. Snapcaps are broken half the time. And
thanks for being a guinea pig. We wouldn't have gotten here without you guys.
Well, thanks. Yeah.
Your feedback was what feeded us into to actually improve Core in the right direction.
Yeah. Thank you. Yeah. No. So this list here is essentially what we've ended up on as we're looking past on, like, if you ignore Core 16, maybe like starting like Core 18, 20, like that's a more generic reflection of that, right? So first, OTA. I must say, it's rock solid. We've only had, at scale, 2 issues that we've seen problems with OTA. The first one is broken SD cards. Not much anybody can do about that, because that's just, sorry, that's a hardware failure. Not really much we can do, more than reducing write to not get there, but that's a different problem. The only really problem we've had with OTA is if the disk gets full, Snapd tend to crap its pants. And that's hard to recover from remotely. So that's the only situation we've really seen at scale where, not at scale, but where we've seen more than once where it happens, right? So that's one thing there. Moving on to security. Very solid. We are very happy with that. Like, that was one of the things I was very pleased with Core, and I was very vocal internally on the selection because of the security, right? Great use of GPG, like for signing assertions, building, validating everything cryptographically. Great use case for that. That really works really well for us. The sandboxing now works really well. The plugs, they're good now. Wasn't always the case, but they're pretty good now. And they cover most use cases, right? So we are able to securely confine processes pretty well. And secure boot, that kind of just works out of the box. Because Canonical has proper signing keys from Microsoft, you don't even need to load up a custom file into your BIOS to actually enroll that. It just works out of the box. Set a flag in your Snapcraft file, build the disk image, assuming the BIOS has it enabled, and it just works. That's really good. We like that. We run our own Snap Store, so the ability to whitelist snaps is really helpful. It reduces, again, the attack vector. If somebody were to compromise that, you can't easily add things in there, either in the supply chain or if you actually get into the device. Really like that. Snapcraft packaging now is very good. It's easy to work with. I mean, it comes without saying that there is some learning curve to it. It's not intuitive. It's not something that people are used to. Like, it's not like you throw a Docker Compose file on them and they just know how it works. There is learning curve. that's just the reality of it. Disk imaging works really well. We build disk imaging in CI/CD. It just works pretty good. So no complaints there. Ability to mix and match versions is really nice. So even if we're running Core 16, say, on the actual Core device, we can still use Core 22 in our application layer, which is really nice, because otherwise it would be very difficult for us to roll this out at scale, right? Because we'd be locked down to like 5-year-old dependencies in our application stack, which would be very difficult, right? So that works really well. And the last thing that I got poked by one of our developers that they really love is debugging has gotten a lot easier. It used to be very, very difficult to debug applications. Now you can use GDB, and it actually just works, and that was a godsend for us, right? Because debugging like tricky bugs without proper debugging tools is very difficult, to say the least. So these are the things we really liked. So here are things that we don't really like that still requires a lot of work. First bullet point, I know is a very sensitive topic within Canonical about documentation. Has gotten a lot better. Initially, it used to be just a forum. For us, that's not enough. Like that's a complement to proper documentation, not a substitute. We still find ourselves relatively often having to like read the source code for things like that. So a good example, we obviously need the GPU to do our playback. It's not very intuitive nor documented that you need a camera interface for that. So there are quirks that still requires a bit of work there, I think, in terms of documentation, right? Boot time, still tremendously slow. It's a pain point for us, and it really, really is a big pain point.
Actually got worse in 20 and 22. But
yeah.
It's a well-known problem.
Yeah, so that's a big problem for us that we are suffering from. The other thing is we have a large fleet of Core 16 devices out in the wild. There is currently no way for us to do an OTA upgrade to Core 20 or 22 remotely. And like I said, these devices are very hard to reach in general. Not only that, like it's kind of our problem. It's not like customer's problem. I can't go to our customer and say, hey, can you reflash this? They will laugh at me, right? That's our problem to solve, not their problem. So that's the problem that we have. And I know there's been some work around trying to fix that, but it's still not there to my knowledge, right?
I think it's there for going from 20 to 22 now.
Okay.
I'm not even sure we will do it for 16.
Yeah.
We might have to refresh it.
Yeah, I mean, they will come to end of life at some point, right? And it's still not EOL'd, so it's kind of fine so far, but at some point it will hit EOL, and then it becomes a real problem, right? The next one's weird. We have spent a lot of resource on this, but we've unable to fully get to the root cause. We've tried Network Manager, Network D. We still have devices falling off the network. We don't know why, but it's a problem we didn't have before. We've written a bunch of custom code to recover from this, like restarting daemons, like a watchdog, all that stuff, but we still have a problem with network stability where devices drop off the network. We don't know exactly why, but that's a problem that we have seen with Core. The next thing is something that is a bit more, I guess, specific to our use case. We have a big snap with a bunch of services within that snap. Setting resource constraints on a snap itself works great. Like, it's super good. Like, it just works. Doing that on a per service level, not so easy. We essentially had to do a really kind of crazy hack where we patch systemd to enforce C group limits on the services. It kind of works, but it really should be like a first-class citizen on how to confine a resource, because in particular on a Raspberry Pi, like it takes one processor to take down the whole entire system, right? So we need to confine that on a per service level rather than holistically on the whole snap. Hardware support is still limited. I think it took, a year to add Pi 4 support after it came out? Not a good track record. Even on x86, there are not that many supported officially hardware platforms. So that is a pain point. And to make matters worse, that if, say, you have an x86 board that boots just fine, but for whatever reason, your network driver isn't in there, which is a fairly common situation because we all know network drivers are weird and Yeah. You can't do that without, you can build your own kernel snap and build it in there, but then you lose secure boot, and like it has domino effect of other things that you lose if you do that. So that's something that it's still a pain point for us. I know there's been work about being able to sideload drivers, but I'm not sure what the state of that is. But it's not a problem we have today, but we have had a problem with this in the past. All right, on to what was surprising. Ogron had a chat about this morning. I was a bit naive about TPMs. I thought all TPM2s were TPM2s. Turns out that they very much aren't, and that there are a lot of weird implementation of TPMs. So our assumption was that when we added support for our x86 board, we can just enable FD and it would just work. Turns out it doesn't because of these weird things. So that's something that was very surprising to us. Splash screen on the Pi is a hack at best. It really should be a native feature, at least for any application where you need a screen. That is a requirement, really. Like you can't show like a load screen of like kernel booting up on the screen in public. That's horrendous.
That's fixed since last week.
Okay. 5 years too late, but yeah, good. But yeah, it's good that we had to work quite a few hacks to get that working. What was even more surprising, and I understand from an engineering perspective why secure boot plus splash screen is a hard one, but it was surprising to us. And I understand why, but it's still a pain point. Like you still can't do a splash screen, even if that's an Ubuntu logo, you can't do that on Core 20 or 22 even today on x86.
You can.
You can today, okay.
20 and 22 only.
Okay, okay. I see. Okay, so that has kind of been supported, but I understand why we can't do a custom one if we want to do secure boot, because for cryptographic reasons it becomes tricky, right? But those were the things that were really surprising to us. And I'm almost on time, so I guess it leaves some few moments of questions. But that's our experience working with Ubuntu Core over the last 5 years. It's been a bumpy ride, but now it feels like it has come a long way, and now it's starting to be a system that works with us rather than against us. So we're in a much better state now than we were a few years ago. But yeah, I understand we were very early adopters, and that's kind of what you get for being an early adopter, I guess.
And thank you for being so patient. Such a good feedback, as I said.
Yeah.
So
Thank you.
It only works if we work together.
Yeah, 100%. Any questions on that? Yes. I need to. Let me just find a microphone here, because I was asked to actually pass around microphones. There you go. Otherwise, the recording will be off.
So this is all Ubuntu Core 16?
Which part?
What do you mean, which part?
Oh, no. Today we're on Core 20 or 22. I'm not sure what we've upgraded to, but we have...
Okay, so you now have the possibility to do automatic upgrades.
No.
OTAs.
Remodeling.
Right.
So new devices are...
Is going out of service in 6 years.
And then the one that pertains to me is what improved in Snapcraft to make it work better, just to make sure we never break it.
Well, testing? I think there are probably better testing infrastructure now. I think there are a lot of... I've learned a lot. I had dinner with John Siegel last night. Like, I learned about things in Launchpad that we can use that would definitely improve with remote build, for instance. There are a lot of things in there that are basically only known to canonical engineers that are completely undocumented. And for us, it's like, oh, that would have saved us a ton of time if we knew that 3 years ago.
Yeah,
so,
remote build it's experimental today. We're removing it from experimental now. It's still not super stable. We are fixing that. And then you said something that was really hard to get started by the nature of the thing. Do you think there's anything we can do to make it not so hard to get started?
Well, it's hard because it is domain specific, right? It's not like Balena where it's just a Docker compose file and everybody's done any level of engineering knows how that works. So it is domain specific. But I think what would go a long way is really good documentation that actually works, because it's the one thing that's worse than no documentation is outdated documentation.
Right.
So yeah, I think that having good tutorials that are actually up to date and well maintained would go a long way.
Yeah, so right now we're actually going to start testing our tutorials automatically.
It's a good start, yeah.
That's all.
That's all? All right,
For
cool.
now, I don't want to.
Do we have any more questions?
Did you try any remodeling?
Wait, you need this?
All right.
Ah.
Did you try remodeling from like 16 to something more recent without the new partition layouts?
Well, so the devices are in the wild on Core 16. We don't touch those because they're production devices. Now, we release new disk image all the time. So like when we produce devices in manufacturing, we download the latest disk image, and that's using Core, I don't know if it's Core 20 or 22, but it's running one on either Core 20, Core 22. So once the device has been deployed, we don't touch it. So we consider that's live now. We don't attempt to make any modification on that.
Right, but that's like not reflashing, but remodeling should be able to allow you to upgrade in the field with the same way just you upgrade applications over and over. With constraints, I understand there's constraints, but it was specific about going from 16 maybe to 18
Yeah.
with the old partition layout still.
My understanding from various conversations with various engineers on the core team is that it's too much of a risky operation of too many things that could go wrong that it was basically advised don't touch it.
Okay.
Because, and I understand why, right? So that's my understanding that you shouldn't really do that.
Can you tell us about more about the network issues you have? Because I'm related to network. I'm a network engineer, so don't you think that's an environment problem?
No, because it happens both in wired and wireless connections. And there doesn't seem to be much correlation. Like it just seems to just lose connectivity. And even some reboot attempt, the only way to get it back is basically power cycling it.
Oh, really?
So, yeah. We tried to restore the networks, both x86 and Pi. So we've had this both on x86 and on Pi, and the only consistent thing is that you need to power cycle it for it to come back.
Do you have like persistent journal enabled in the field?
Not on the Raspberry Pis, but we do on the x86.
No hints on what went wrong with the network when you
No.
reconnect?
Not that we've seen so far. We analyzed a ton of logs because we do log shipping as well, and we've analyzed a ton of logs, but so far we haven't found any correlation or any like clues on what it may be. Like our latest clue is probably that it's memory related, that something just caused the device to hang or freeze properly. So it might not be a network issue because all we know is that the device
Don't see it.
drops off. Yeah. So it could be that it just crashed. Like it could be core dump or kernel dump, right? Kernel lockup in theory.
Do you have like a reboot at 3 a.m. just in case?
No, we don't. And well, we have some reboot. So basically, we wrote our own watchdog that does a bunch of logic and like, if the network has been offline for X hours, then do this. If it has been offline for this long, do that. So in theory, it should recover, but it doesn't recover. So the last step in that tree of recovery is a reboot, but it doesn't actually seem to work in all cases either.
Do you have a hardware watchdog enabled on all
I
devices?
believe so, yeah. So in theory, it shouldn't be a problem.
Well, yeah, depending on which part crashes.
Yeah.
The watchdog
At least
needs to be
the
checked.
Well, yeah.
service should be able to reboot the device.
Exactly.
And if the watchdog service dies, and you could reboot all the way.
If there's a memory issue and the watchdog can't spawn, and then yeah, it could. Yeah. So it's something that we've been scratching our heads with for the last 3 years without finding the root cause of.
Have you tried the other way around, like not watching from the device side, from the other side?
We've had customers have done that, and they basically say that it stops pinging, responding to pings.
Okay.
Do you send like the fact that the device was rebooted through a watchdog back to some like monitoring service?
I need to check with the engineering team to see if we do that. I think so, because the watchdog does have its own set of logs. I believe so.
No, the hardware watchdog.
Oh,
When you
I mean that should be
boot
in
up a
system D
platform,
logs,
you
right?
Look at the kernel.
Yeah.
The boot reason is like hardware watchdog, right? You can then correlate that.
I need to
back there was
dub-
some failure.
Yeah, I need to double check with the engineering team to see if we actually do that. But that's a good lead. But yeah, so far we haven't seen any. Well, I'm pretty sure we haven't seen that because then we would have. Well, I need to double check to be honest. Yeah.
It's sometimes hard to look depending on the platform, but it's like
Yeah.
every time it's a blip, it's like it means that the last line of defense was the one that's.
Yeah. Yeah. Okay. Yeah, I'll take a look at that. But yeah, it's been an interesting one.
Yeah, it's weird because you are not our only customer. Obviously.
Yeah.
We have quite a few now, and
Yeah.
I haven't heard that from anybody.
But I actually experienced this myself, not on core, but there's a batch of devices supposedly identical. We can replicate like a hard crash down to we don't know what's going on in the kernel. It's literally dead completely. In this device always, and this device never. They can like,
If you say not on core, it is Ubuntu, but not core.
I mean, it's some build of a kernel, but the point is that we don't really understand the difference between devices. And on one device, you really can reproduce a crash quite reliably, not on the other. Sorry, yeah. And it's still a mystery to us. It's not really related to Ubuntu Core in the sense. It's like it's like you put it in a reboot loop, and at some point it's just gonna die hard until you yank the power cable. But only on some physically manufactured devices which are identical from everything that we know about them. I don't know, maybe it's something interesting, cosmic rays. But I really don't know. Not cosmic rays, obviously, but
Ghosts.
ghosts. Yes. But it's really mysterious because it's like you can halt a project for a long while because it's like a serious issue at scale. But what do you do?
We've started like model out uptime across our entire fleet essentially to see if we can spot any visual patterns. Like we try like machine learning on the logs to see if there are correlation. Like we've gone through pretty long.
Already sounds expensive, right?
Yeah. So we've gone through pretty long lengths to actually try to find the root cause, but so far we've come up short, which is weird.
Packet capture.
Yeah.
Are you using any like microcontrollers or on some of the SoCs to do anything? Like a separate
No.
core running not Linux, but just some random piece of code that you want?
No, it's Nexus is just it's basically like a nuke. So
Yep. Yeah,
nothing
okay.
specific on the device.
Okay.
So, I think we're on time, unless there's somebody want any last question.
Yeah.
Yeah.
Do you want passing mic?
I'm not sure. I'm not sure how strict they're on time. So
Yeah.
yeah.
I was just going to ask what you need from the graphics driver point of view. Are you aware of the graphics core 20 interface that we on the Mir team have been pioneering? And what do you want? Like some of the stuff on our upcoming roadmaps is getting Snapd to do that well. What are your requirements there?
So currently we use Frame Buffer largely for all the video playback and for Qt as well. Now we are exploring the next version because Qt6 made some changes around this. So we are looking to adopt Wayland or Mir or something like that for the next version. It'd be good to sync up one of my engineers to see what they would think because I don't have enough first-hand experience of what we would want. But I would love to have a conversation. I'll put you in touch with one of our engineers to see what they think.
Cool.
Amazing. Thanks a lot, everybody. Cheers.